Hello everyone, this is Harrison Galway, and today I'll be teaching you how to factor using the difference of squares pattern. So, as often happens in math, the name of the topic is a good description of exactly what it is. Here you'll notice that we have a difference, in other words, two things being subtracted or something being subtracted from something else, and that both of the terms here are squares of something. And when you come across a expression like that, it can be factored. And the pattern is always the same. It's just a minus b times a plus b. So let's look at this using a couple examples. So the first one here we have x squared minus 9. And we immediately see it's a difference. And that both of the terms are squares of something, right? What I like to do when I'm factoring differences of squares is to write out explicitly what squared gives me the first term here. Well, clearly that's just x, right? And what squared gives us the second term? That would be 3. And by doing that, you've identified a and b in the pattern, right? This is a and this is b. So factoring it is then really easy. We'll just do the first term minus the second term times the first term plus the second term, and voila, done. Number 2. So again, it's a difference, and these are also both squares. What squared gives us 4x squared? Well, you got to be careful, right? Because you need to think both of the variable term and the coefficient here. So the answer would be 2x. 2x times 2x is 4x squared. And what squared gives us 25? Well, that is easier. That's just 5. And there they are, right? Those are a and b. So factoring it, we'll just say 2x minus 5 times 2x plus 5. Done. So really, the work is just writing these down, and then you can just throw it into the template pattern, and you're done. On to the next one here. We have x to the fourth minus 16, and you'll see this is a higher power than squared, but we can still think of it as a squared, because if we just think about this exponent rule, right, where if we have some exponential raised to a power, we just multiply these two exponents. This is x to the a times b. And so the question then is, what squared gives us x to the fourth? And the answer, thinking about that exponent rule, is just x squared. What squared gives us 16? 4. What are our factors? I'm going to give myself some room here. That's just going to be x squared minus 4 and x squared plus 4. However, for this problem, and this is a really common theme for all factoring problems, is that you always need to make sure that you factored completely, that there's no more possible factoring that you can do. And if we look at this first factor, it's also a difference of squares and can be factored further. So the question then is, what squared gives us x squared? That's just x. What squared gives us 4? That's 2. So we can factor that one into x minus 2 times x plus 2. What about this second factor? Well, there's no sum of squares factoring pattern, so we can't factor that one out. We have to leave it. It's just x squared plus 4. It can't be factored any further. So that is that for that problem. On to the next one. The next one says x to the 8th minus y to the 12th. So again, thinking about that power property, or property of exponents rather, when we ask what squared gives us x to the 8th, x to the 4th, what squared gives us y to the 12th, y to the 6th. And then we write them out. X to the 4th minus y to the 6th times x to the 4th plus y to the 6th. But again, this first factor is still factorable because it's also a difference of squares. What squared gives us x to the 4th? X squared. How about y to the 6th? Not too much space here, but that's y cubed. So we can factor that first one more, and it becomes x squared minus y cubed times x squared plus y cubed. But again, the second one up here, this x to the 4th plus y to the 6th, we cannot factor it any further because we cannot factor a sum of squares. So we leave that one alone, and that is it. Last one, it looks more intense, but it's really not any worse if we just think about each of the terms here sort of on their own. Because going through, we notice that each of them is a square of something, right, for both of the terms. So we can just sort of think about them one at a time. What squared equals 36? That's just 6x y squared. And for the second one, what squared equals 49? That's 7a cubed b to the 4th. And then we just write them out. So that'll be 6xy squared minus 7a cubed b to the 4th times 6xy squared plus 7a cubed b to the 4th. And there's nothing we can do. No more differences of squares. This one's not a difference of squares because of the 6 and the 7. They're not squares. A cubed you can't write as a square. So there you have it. That is how you factor using the difference of squares pattern. Thank you for watching. Please check out my other videos and take care.